Well, hello everyone. You're gonna have to bear with me. This is my first time using an audio presentation like this, but it should go pretty well. Anyway, my name's Jordan Bauer, and my article review is going to be on tortoises in the Galapagos that have become extinct, and Elizabeth Hunter and her crew is trying to take two phenotypes and see if they are going to be viable replacements for the extinct Pinta tortoise that was once there. So here we go, let's dig in. So I put together some main goals that I found that were best fit in with this study, and one of them was, they wanted to determine if, there was a tortoise out there that would be able to replace the extinct Pinta Island tortoise, and I'll get more into, that tortoise as we get along here. But anyway, so yeah, they used two phenotypes. They're, can any tortoise, take over this extinct species, or do we really have to put in some step-by-step effort here to figure out what species would be a viable replacement? So they used two phenotypes, and they'd hypothesized that they would exploit different elevational niches. And we'll take a look at the geographical layout of the island here. And then this would in turn look at the different effects that each tortoise would have on the Puntia cactus. And we'll go more into that in a little bit here. So here are the Galapagos Islands. They didn't have a very good map in the article, so I found one here to kind of show where everything is at. The island that we're curious of, and they were, is Pinta Island. It's been through a lot of changes over the past 100 years, from pirating to introduction of invasives, to human interactions. They're trying to restore us back to its original state. Um, So anyway, this is the Pinta Island. It's the most northern island of the archipelago here on the Galapagos Islands. Santa Cruz down here is where the Darwin Research Center for tortoises and their big, research facility that they had there in from when Darwin explored all these islands and made the observations. This is where he put everything together and did his research. So if we look a little closer at the island here, it was once a shield volcano, much like some of the volcanoes in the Hawaiian island chains. So it spread out really broad like this, and you can see the actual crater where the now past volcano is. And in the northern, you can see where the lava, it's still lava fields. In the northern and southwestern part of the island, it's those blackish areas. But you do see a dense wooded green area in the middle there, in the highest elevational range that where the crater is at. And then you can kind of see some clouds there. This is just an aerial photo, just kind of show you what the island looked like up close. So here we go. We get into why are they deciding to do this? Why are we trying to conserve this ecological function? All right. And their main driver for this, and a lot of different species rely on the prickly pear cactus, or Opuntia, on the island. It serves as a keystone species in the arid region of the island, and that's right around the mid-elevational range of the area. Keystone species, all the other species in the ecosystems, they kind of rely on this one species as being, what they look to have the biggest effect for the ecosystem. If the keystone species were to, dissipate or lose, or I don't know, leave, it would be catastrophic for the ecosystem. And like, Dr. Bessert talked about in his presentation about the American alligator. But anyway, I digress. So this is the prickly pear cactus that is so important for the island. It works wonders for the other species in terms of protection, shade, homes for them, and so this is what the tortoises come into play, is that they are very good in doing or having seed dispersal throughout the island. And I'll get into more of the morphological shell structure of the tortoise, but they are the ones that disperse the seeds over the island and make it available to all these other species. So back in early 19 or 20th century, Darwin came along and he saw these tortoises, and through countless ratings of pirating, or pirates come to the island, and all the explorers, they really devastated the population. And I saw some links and read some papers that these people would just come along, take the tortoise, and leave them on the ships and use them for meat, because they'd last so long on the ships. They'd be fresh meat for them, just have them lay there. So they were really over harvested in the 19th century and 20th century. Well, not so much the 20th century, but 19th century. And the last known individual was Lonesome George. And if you want to see a great video, click on the link there. I hyperlinked it to a 5-minute video, and in 1972, Lonesome George was finally taken from the island and placed in the Darwin facility to run research, and they tried to reproduce with it with other females. They had two or three instances where they had actual eggs, but none of them hatched, so they all died. And finally, in 2012, I think he was 120 years or so, which is not too old for a tortoise, but in 2012 he eventually died. And the New York Museum, if you click on the link, they took him from the islands and made a replica of him to put in their history museum there. So it's actually pretty cool if you want to listen to it. And this is Lonesome George. So definite saddleback shell shape, and so that's where they tried to look at the phenotypes for him. So the background to this, so they looked at taking two different phenotypes. One is the saddleback and one is the dome tortoise. So a saddleback morphology, it has that really tall, you can see it there, where he can lift his head up really high and get those cactus up on the tree like that. And in a lot of other islands, the cactuses are actually really low, or pretty low to the ground. I mean, they don't extend up above a few feet or so. And over time of these tortoises consuming them, they eventually, they reach like 8 meters off the ground. It's ridiculous. It just over time they adapted to the herbivore, using them as their resource. So they grew really high, but in turn, the tortoise also adjusted for having these shells like that. So they could reach up as high as they could to get those low-hanging pads. And since the cactus was only most abundant in those like semi-arid kind of desert-like conditions, this is where the saddlebacks were. And the dome tortoises, before the study, they knew that they like the higher elevations, and which in turn the cactus was absent from those elevations. So they wanted to see if in fact they didn't have any relation to the cactus, and if it was being used or not. So, but the one interesting thing that the authors and known to be true about the dome tortoises is that they do venture to lower elevations, which I'll mention this later, but it could they could be a factor in distributing the seeds as well, but I guess that's to be researched later. And this is the dome tortoise here. He wouldn't be able to reach his head real high like the saddleback there. So it's actually pretty interesting, just the morphology of these two the shells that they have here. So the study design, what they decided on using was 39 saddleback and dome tortoises, and these were taken from Santa Cruz, like I said. Most of them were taken from there. They from the conservatory or the Darwin Center. They grew them there and kept them in captivity or whatever. So as you see in the picture in the upper right, this is the actual transportation of these tortoises to the island. It was quite the effort. I mean, they went on a few different boats to get them there. It was pretty neat. I watched a couple videos on it. So they had 13 domed tortoises and then 26 saddlebacks. 4 of them were actual saddleback phenotypes, and the other ones 22 semi-saddleback hybrids. That was from breeding in the facility, in the Darwin facility, but they just grouped them as all saddlebacks. And another important note to make is that they were all sterilized, so which meant, and they explain this in the article, it was important for this in case they had future introductions of more tortoises, and having them sterilized like this. Also, the researchers were able to look more at them using the resources and feeding and focusing on that more so than reproducing or nesting or that sort of thing. So they wanted to look at the ecological functions more so than the reproducing part. So to test their hypothesis, they monitored the movements of the tortoises, and this was done by equipping these tracking devices, GPS and satellite tracking, and they also had GPS loggers on them, which kept hourly locations and time, it gave them the information right away. And they used these couple different devices as ways to be most productive in getting the data as well as cost effective. And if you look at the picture there, the dome tortoise there has one of the tracking devices on his back. So they just, I don't know how they stayed on there. They must have glued them on or taped them on. But yeah, they stayed on throughout the entire time. And so they monitored these movements and everything for 2 periods, monitored 2 times for 2-month periods. So one was the first year in 2010, right after they released them, which was in mid-May or so. So they pick these dates because that's when the cactus was most abundant during that time. It was kind of the rainy season for them, so they were pretty dispersed over the area in abundance. So, and they also carried this study. It was a 2-year study, so they carried it into 2011 as well for consistency in the same dates. So then, on top of that, and which was also really interesting, so if you look in the top right map there, they brought them up to basically the mid elevation zone of the island, and where the cactus was most pronounced or rich in population at that point in the island. And believe it or not, they remember back how they carried them up there on a stick like that. It was 3 kilometers. So I guess imagine going in one of those 3-kilometer races or whatever, trying to carry 39 of these tortoises up there. It's pretty interesting that they went through all that work for that. So it's pretty cool. And I love the picture in the bottom right there. It really shows how those saddleback tortoises have that ability to reach up that high. So pretty interesting. So in 2011 and 2010, they just relied mostly on the the device, your tracking devices for getting their data. And in 2011, they really focused in on behavioral activities. They sat down basically with the tortoises and worked or just observed them. So there were 7 focal saddlebacks that they looked at, 2 male, 5 or 2 female, 5 male. They observed them 3 days in a row, and then had a 2 weeks in between, and another 3 days, and so on and so forth. And then each day they looked at for 7 hours, which is quite I think it's quite a long time, observing a tortoise, being that patient for that. But it needs to be done. It is a great way to put all this data together. So what they observed was a lot of foraging, resting, moving, scanning, social interaction. These are all basic things that a tortoise would do for them. And then in 2010, 2011, they collected also feces, and this was, for that seed dispersal of the cactus. And, they needed to keep it, for them to collect and get a good sample, it needed to be moist. So I believe they would definitely probably kept better samples, I guess, if they wanted to explain it in that sense, in 2011, just because they were observing them, for most of the day. But anyway, so as for the statistical analyses, to get some environmental variables, they used ArcMap. And this, they used the elevational data of, from maps, actual maps, and then they determined the slope, and they also then took a lot of the vegetation and made it into 4 classes, based all the way across the island, and 0 to 4, or 0 to 3, sorry, 0 to 3, 0 being no vegetation, 3 being most. And they looked at each of these classes. So, and then they put in 2 some different models. I guess the easiest one to use here for determining niche differentiation was just determining the average weekly elevation, and this was carried on throughout the year. And then they used Welch's t-test to then for the sample size and the variances. So that was a relatively easy step there. Well, to back that up, they use species distribution models, and they used a software for doing this, and MaxEnt. And basically, what I understood this as is, this described these were the 3 variables: elevation, vegetation, density, and slope. So these were basically what the tortoises, how they varied from each other, which variable was best depicted as showing a variance between each other. So were the tortoises, in a high vegetation dense state most of the time together, or was elevation affecting them most, or slope? So that's what they based those models off on. So to get into more of the in-depth modeling, they looked at resource selection functions for the different variables that they observed for both tortoises throughout the 2 years. And these were basically, in our case, used to identify the interactions between the tortoises and their vegetative choice, or the other variables, which I'll show you here in a second. So basically, the RSFs proportionally between the variables describe the probability of the tortoise, or an organism or species, to use a specific resource. So the models that they came up with and the information that they gathered, they created these 8 models, and they did this using a Keiki information criterion, and this was based on 3 data sets. So Dome 2010, Saddleback 2010, and Saddleback 2011. Now notice that the Dome 2011, there is none. Okay, there's nothing there, and I thought that was a little interesting, and they probably should have, or I think they should have showed that as well, just for consistency. But at any rate, so their variables of choice were the topographic slope, vegetation density, and then the adult cactus density, and that they described as there has to be bark on the trunk for that to be an adult. And then based on this criterion, AIC, they ranked these models, and I'll get into this more in a few minutes, but they ranked the models, and the best model, or the parsimonious model, was indicated by the lowest AIC value, and then by the highest weight. So a best model can be described as what the other models are then based off from, and I'll get into more of this in a little bit, but then you can kind of see the interactions between the different variables. So the best model is what they will use for their analysis. So as we get into the results, to show the niche differentiation between the two tortoises, they use the results that they are, the data they gathered from the average elevational ranges of the tortoises over the 2 years. And as you see in the upper graph there, the dome tortoises just went straight up to the higher elevations. You can see basically a linear line going straight up the hill to those higher elevational ranges. And as you see why in this graph down here, they went up to those heavier forested areas. So the mean range for the dome tortoise was 356 and the saddleback 280 meters. That's a pretty distinct difference. And if you remember back, the species distribution model that they used for the one program, elevation, between the elevation, the vegetation density, and then the slope, they found that elevation was the biggest indicator showing that these tortoises deviated from each other. It was the biggest variable that they found contributed to their niche differentiation. And when you look at the map too, you'll see that this graph shows the saddleback at a much larger area, and this area, contributed to those cactuses shown in that mid elevational range, while in that black range up by, if you remember back to the map, was filled with, you could see from the satellite image, that green, dense green area, and that's where the domed tortoises went. And then that X there shows the release site of all the tortoises. So right in that area where the high populations of Opuntia were, and then the dashed lines show the area with no vegetation, basically. Those were the lava areas. So then when we look at these resource selection functions, as I said before, they showed the interactions between the different variables that they used. So basically the 8 models they came up with showed the relationships between C, as in this case was the adult cactus density, S was the slope, and V was the vegetation density. So you can see the different combinations they came up with to describe the various interactions that these tortoises could have had on the island. So the data set for the domed 2010 tortoises, if we look at the AIC value they came up with, 0 is where we want to look for the best model, the parsimonious model. This was the lowest model with the highest weight, but notice that the slope and the vegetation, those two combined, as well as just the vegetation density and then the null hypothesis, those were all really fairly close, and the author described that even the null hypothesis didn't have a significant difference from that highest weighted value for slope for the dome tortoise in 2010. And as we recall, null hypothesis is basically there's no difference between any of those interactions. They're all the same, so each tortoise exploited those equally. Well, we know that in this sense, and especially the saddleback 2010 and 2011, that was not the case. And if we look at the next data set there, 2010, that showed for the best model an 81 weight, which is way above pretty much all the other ones. And then also in Saddleback 2011, in this next graph, we'll kind of see that. So here you go. Explain. I just put it on there again. The best model was determined by the lowest value and then the highest weight. And this table basically just condensed it down. So if you look way to the right, it shows the AIC weighted weight for each of those data sets. And also notice that the sample size for each of these are kind of low, and that I believe was a problem on getting a good significant difference between some of the variables as mentioned before, and as the authors pointed out. But nonetheless, as we look at the first data set there, the Dome 2010, the significance here is that they did not feed on the cactus. That's the key here. They did not feed there. This slope, you don't really need to worry about that. I mean, it's a negative value. You know that if they didn't feed on the cactus, they probably went to higher elevations, and that was showed and shown in the other niche differentiation analyses. But anyway, if we move on to the Saddleback data set for both years, they both relied on the cactus for one of their prime food sources. But then we see a little deviation away from that in 2011 when they are feeding more or spending more time in the high vegetational dense areas there, and this could have been just because they were observing them more. I'm just throwing something out there, but they could have just they observed it so closely that year. They spent those 7 hours a day that they got a really good weight. They were really able to narrow down these values for those 7 individuals. And then also what was pretty interesting, so in 2010, and when we start talking about seed dispersal, they, out of all of them, now domed and saddleback, they had a 6.6% of 61 samples. Those contain the cactus seeds. But then in 2011, 36.8% of the fecal samples, those contained cactus seeds. So you can see a big jump there, and that could be, again, they spent a lot more time getting the more quality moist samples that they were looking for in the focal individuals, saddleback, that they looked at more closely. But nonetheless, this shows they are good for seed dispersal for the Puntia cactus. So as we move into discussion, they found out not all tortoises can meet the needs of any one desired niche. So that's an important finding, or I guess not finding so much, but emphasis on that. And this just proves that you need to take careful consideration. You need to plan out, if you're going to do these ecological replacements, you need to do your homework. And use a couple different species, figure out which one's going to work. And so in this instance, the domed tortoises did not inhabit the areas abundant with these Opuntia populations, the keystone species of the ecosystem there. And so, this was also confirmed a year later, just to back it up, in 2011, that they were staying at these higher elevations. They weren't, deviating all over. They had these tracking devices on them. They knew where they were going. So they stayed at those higher elevations where these Opuntia populations weren't living. So just kind of reiterating the fact that these tortoises were not fit for a viable ecological replacement for the Pinta tortoise. And then also, which was another good point they made, and they placed all these tortoises in prime populations of the Opuntia cactus. So I mean, the dome tortoise had all the opportunities to go feed on these, uh, um, this vegetation choice, but they chose not to. They just went straight up uh, to a different elevational range, different vegetation. They didn't feed on this type of food source. So that was a really good point that they also made here. So what fulfilled this then? The Saddleback did, obviously. They kind of took the reins of what once was the Pinta tortoise. They stayed at those mid-elevational ranges where that Opuntia cactus was most abundant. They more dense. And another one of the things, they spent over half their foraging time on the cactus, and that's when they observed them in 2011. So they concluded, can conclude that the saddleback tortoise can hold as a viable source of Opuntia seed dispersal. They lived in that area. They had feces filled with the seeds, higher in 2011, and they could disperse it where they please and in the right environment for the cactus to grow. So they also found out that trial introductions are important. You need to try a couple different species. You just can't throw a species out in an environment, and even if it's a phenotype or a subspecies, you just can't throw it out there and hope that it's going to fulfill all of the requirements that an extinct species has. You have to do your homework. And then did the ecological functions restore? Are they going to be restored? Now, this is a big change, and I thought about this as well, but when they took Lonesome George off that island, it was in 1972. And that's close to 44 years or so since, or roughly, since that time that last tortoise was on there in its native environment. And then since that time, there's been history showed there was goats that really devastated the landscape on the island and brought the vegetation down and changed a lot of the characteristics of the landscape. But now that those were eradicated a while ago, bringing back these tortoises could have a different change, but it'll bring back what was actually there before the last Pinta tortoises were eradicated from the area. So there are a few unanswered questions and weaknesses that I found, or I thought of in the paper. What about the importance of the dome tortoises during nesting migration? I hinted at this before. That they might come down, from those elevational ranges, come down and use that Opuntia food source. But I mean, that's just another question that they can answer, or by introducing more individuals that are fertile and that can reproduce. So that's future research that could produce some good data. So how is the vegetation adjusting to the new population? I already the reason why I emphasize new is because 1972, from that long ago, 40 some years ago, how are they going to adjust to these the vegetation to these new, giant herbivores in the area. And I mean, a lot of the finches and lizards, the other species, how are they going to be affected? I One of the articles I was reading, just kind of like a little blip about this article. Elizabeth was kind of Elizabeth Hunter, the author, was explaining, when these tortoises took off from their let-off zone in the middle of the island there, they basically flattened, and you can see it, some of these images and videos if you look it up a little bit, but they basically flattened down a lot of the grasses and high brush, and the birds and some of the different lizards and iguanas, came where they flattened everything, probably to pick up some of the seeds and insects and stuff like that. So it was kind of cool seeing how different species were taking effect right away. But going back and in a few years, from 2011, and seeing the different effects that they had on the other species is pretty important. They could have used a better aerial map of the island. I mean, I put one in there if to relate, to where the Darwin Center was, or the vegetation and stuff like that. And I also, wanted to say, larger sample size, you wouldn't have that insignificance, possibly you wouldn't have that insignificance if you would have a bigger, sample size, and would it explore, more some of the domed tortoises, not only for 2010 but also for 2011, and do some more observations. Now, Saddleback was the primary tortoise here, what they really relied on, and was looking as a replacement. But still, for research and data purposes, I think both of them, equal purposes, should have been more included into the paper. And this is where I just stated again, there was no data for fecal samples for the dome tortoises in 2011. And then also the density maps for like the vegetation, I think it would have been for the environmental variables for the cactuses, or for the puntia, those density maps from ArcMap, I think those might have been for visual purposes. I'm more of a visual person, so it would have been nice to see those. Overall, I thought this study introduced and emphasized important approaches to conservation, sustaining natural ecosystems. I like their use availability design, which, these cactuses were available, but did which tortoise use them? So basically that's what that means, which used them more, and obviously the saddleback, use that resource. I can only imagine the patience it must have taken to observe them for 7 hours each day. And I watched just a couple videos, and watching them for longer than a couple minutes, I can only imagine. But anyway, they did a great job, I thought. I do believe further analysis is on the dome tortoise could have been used to strengthen the paper, even though a saddleback tortoise posed as a primary replacement for the pinta tortoise. Introduction of fertile specimens should be cautioned, as little is known of the carrying capacity of the island and what effects a large population might bring. So that's another thought they might want to consider, is how many they want this population to grow to. But then again, as a natural process, they should let it go and see what it brings. They might bring down a lot of the vegetation again on the island, but to bring it back to its natural state, that's part of the evolution of the island. If it'll reach its carrying capacity, and it'll work its way out. So Anyway, I hope you enjoyed this article review, and hope to see some good discussion posts. Thanks for your time.